Hello, my name is Jack Northcutt with team number 10, Project 19, the Solar System Designer. I'm going to get right into our user perspective of the project. So as you can see, this is a WebGL HTML5 build of our project. It's hosted on GitHub, and we give it a domain name, solar-system-designer.tk. It can be viewed anytime, anywhere. And it will be updated after every sprint. This is to help our sponsor be able to anytime check in on a project, and so he can always get a good visual and show his colleagues. And as you can see here, this is the user's perspective of a project. Currently, planets are rotating around a star. This is all built by us. We weren't given a base model for this or anything. And you can see the planets rotating around, some bigger ones slowly. The planets are not on a using physics just yet. They're using a rotational script for demo purposes, so you can see it. Everything has been scaled to actual sizes, but then for this of distance and mass. But for this demo, we increase the sizes of the actual planets, just so you can see them, because obviously the sun is so huge in comparison. But the user can move the view around, kind of look around the space, and see different planets floating around, and they can zoom out or they can zoom in. And they have a list of menu options, such as add object, and they can pick planet, star, moon. Currently, you cannot insert these objects. We had it to where you could, but decided to take it out because it wasn't using physics yet, so it would just plop basically a blob in space, and it would just sit there. So we wanted to wait till physics was integrated to get those going. Also got a console menu for debugging purposes, so we can later test aspects of our project and review log information. And now we'll move into the code base. You can see here, this is our Unity project, and this is the same project you were viewing in the WebGL build. To our left is our solar system scene with our menu, our camera, our lights, our console, and everything that you view on there. Down below is all of the code, and a lot of this is basic Unity code, but here we own this test. The skybox is created by us, but not the actual images themselves. And you can come down to the scripts where actual code is, and we have it broken down to a few different sections: in-body, planet, solar system, test, UI, and util. And then down here, SimCappy is actually all our sponsor stuff. Code he provided for the Smart Sparrow API connection. And this is so we can communicate with Smart Sparrow API, so a instructor can create a lesson based on our simulator. And then obviously the basic Unity packages. So far, I think we're in a really good spot in our project in accordance to the project plan. I mean, we got all the basic stuff set up, and we're ready to gear towards integrating the full physics into the project. Physics backend has been written, and we're just waiting, getting everything just together so we can implement that. And so we are right on track with our project plan. Just to show you a little bit of the code base, we have this gravity class, which is going to simulate the gravity between a star and a planet just by mass and distance. And we got some calculations. It's going to return a vectored position. A lot of these formulas we got from a lot of research. An ellipse class. This is basically going to get us information, just additional information. It was going to be used as a primary focus of the project, but decided to use it more as an information class, such as getting the eccentricity or the foci positions or calculating just minor things. The in-body class is going to be our collection of bodies in a system. So it's basically our collection class. Solar system model is just going to be a test class used to load in a model of bodies or an in-body system. That way we can do testing. Our orbital body is a main class we're working on, trying to get a class set up that's going to communicate with front end and back end code, and so we can get our physics integrated. Our body class defines if it's a planet, sun, moon, asteroid, and then sets it up accordingly. And then the debugger is the console window I showed you, along with its UI settings, and then camera controls here. These are not all our classes, but some of the main ones I wanted to highlight it, and some of the recently added ones from our last sprint. Now we're going to jump into some of our artifacts here. We have our GitHub account, pretty organized in different file sections. We have this time card artifact in our GitHub. This is Google Drive. In our Google Drive with time stamps of how long it took us to complete certain tasks, and we're going to use that information into order to better set up the next sprints and to better adjust the user story points. We got also a couple guides like on physics with a bunch of links and some information in our own words of how we thought it was, and a Unity guide. We had trouble setting up Unity in the beginning, so this was a good guide to help us get set up in Unity. Here's our Taiga, and we have a many wiki pages, but one important one I wanted to show you was a body of knowledge page. This is where we list all of our tool chains, our Git integration, and all of our requirements and rules we set for ourselves into order to better format everything. And anytime we get new information or find a new process that might work better, we'll add it into here. And we have everything stored in here as well, our UI mockups, and as you can see, it'll take a minute for the pictures to load here. But we got our UI mockups, but you already seen the UI. Here's our current sprint. Just want to highlight some things that I've already went over, like let's integrate the WebGL, which we did the gravity model, and integrate the scaling, which I talked about, the camera functionality, hosting on GitHub, some CAPI control stuff that it's hard to show at the moment, but some other user interface improvements, and the work on the orbital body class. Then I kind of want to show you our GitHub account a bit. In our GitHub is our last repository, and I just kind of wanted to go over, just show you that how our formatting is. We try to keep everything organized. We do have a few outliers from our very first sprint, some mistakes, but we try to keep everything in a fashionable order, creating our demos. And this GitHub pages is actually what serves our actual GitHub site. This are the website that you saw in the WebGL build, and it has to be named that for it to work. Some other nice things. We'll go over this again. And I just wanted to show you some more about our tool chain. We all use Unity, obviously, and Visual Studio a lot. I use Sublime just to show you that's easier to show you a bunch of different classes. SimCAPI is that API I showed you in the code. GitKraken's actually just a Git tool. It just makes it easy for us to better manage our Git so nobody overwrites somebody else's stuff. And that's our project, and I think we are on a good track at the moment in accordance with our project plan. Everything seems to be going pretty smoothly. Some ups and downs, but I think we are in a good position for the next semester and getting this done well within time. And we will be working through winter break to get everything else straightened up. Thank you very much.